Cyrus, you are here from WorldCast,
That's right.
and you're going to talk to us about codecs today, especially virtual codecs. And I think that's something that we all want to give a little attention to. Many of us are using systems that you've got the A to D, D to A, A to D, D to A chain in some older stations. I remember one station from a major consolidator here that had a four conversion before it got to the audio processor on its way to the transmitter. And yeah, you can have some really good results depending upon your codecs, or you can fight with them. So, Cyrus, tell us what you've got to talk about, and you're going to have screen here so that
Okay, great.
you can share your screens or whatever you would like to share with us and educate us, please.
Oh, that'd be great. Thanks, Barry. Thanks for having me, and thanks for inviting us. It was nice to actually meet you at NAB this past April, and to be able to come on the show here. I First of all, for everyone, my name's Cyrus Uible. I do work for WorldCast Group. My title is a solution architect, but I'm also an applications engineer, helping out with a couple of our product lines. Most of my career has been on the software side of this business, um, mostly also on the vendor side of this business. I have spent some time doing some contract work, I would say, on the broadcaster side. Um, I do primarily work on the engineering side, for our company. So I'm typically involved in projects, helping out with support, and occasionally I get talked into or I get voluntold to help out on the marketing side. So I will be completely transparent in that I'm a little bit nervous talking to a bunch of, I would say, real engineers. The for myself, I consider myself, as a software engineer in this business. I like to play around with stuff and fix stuff, and so I have a fairly good understanding of how these things work, but I don't always have the intimate knowledge of how they work in the real world like you guys do. So bear with me a little bit as I kind of make my way through this. Barry, I am going to try to share one of my screens here. I think I do this through let's see here. Remind me where I go. I go to
Little
share.
green
Share.
thing at the bottom, share, then select the screen and then click
Perfect.
on share.
Perfect. Thanks for that reminder.
It's coming right up here. Do you want us to hold questions or put questions only in the chat or just ask you as we go along?
You can feel free to ask as we go along. I enjoy questions, we'll see. I'm happy to answer as we go along. Gives me other might lead to other interesting topics.
All right.
I um I will just quickly, if for people that aren't familiar with my company, WorldCast Systems, because we are a French company. We are based in Bordeaux, France, and we have four major product brands. APT, which is what I'm going to be speaking mostly about today, is our audio codec, audio transport brand. Acriso. Acriso is our FM transmitter brand. Aldamet. Aldamet is going to be our, I would say, high-end or more technical FM monitoring brand. And then lastly, Kibio, which is our network management product. So I help out across all of our brands as needed. We're not a gigantic company, so we do help out. All of us, no matter what team you're on, helps out across the platform. But I mostly work on the software side of this of our projects, so I'm going to be more versed in some of the virtualized APT stuff, which I'm talking about today, as well as the Kibio stuff. Now, that was and just to talk about where the pieces that I'm talking about today. I'm on here, Barry, to talk about our virtualized codec now, or as are starting to call it, our software codec. And I can see in this picture here, we're talking about, I got a studio output here getting to an antenna. And I'm talking about these codecs here, this IP codecs on either side of this cloud here is what I'm talking about today. Now, we've been making codecs for a long time. We have equipment, we have boxes out there that are, been out there for decades now. The history of our software codec was quite simply that we wanted to take that codec out of the box, create a software appliance version of it that could be easily deployed, easily scaled, easily managed. And that's essentially kind of what we did. In fact, if you log into our virtual or software codecs, the actual GUI interface that you see is exactly the same as our legacy. I'll call it legacy, although we still make them, we still sell them. They're still in demand. Our legacy codecs. Now, let me get out of that one, and I'm going to go into. I'm going to just quickly go through the brochure a little bit, just to hit some kind of overall points, because I do have a more technical presentation that I'll get into in a second, but this will ideally, gosh, that's a little bit hard to see. Okay. So I'm going to assume that you guys are pretty well familiar with, virtualized appliances and what some of the benefits of that are. Part of what we do is we're going to be featuring the fact that our virtual codecs are going to be supporting APT MPX. This is our compression for MPX that we believe is the best quality for especially in lower bitrate environments. It's mentioning here in our brochures here the shift to virtualization, reducing the amount of equipment to purchase and offsetting upfront costs. Because really, what virtualization or a software version of these things, much of the driving force behind it is saving money, because and also I would say speed of deployment. So if you've only got, let's say, one codec, the speed, the difference in setting up one virtualized codec versus opening up a hardware codec box and putting it in a rack, maybe you won't see that much of a difference. But for us anyway, the virtualized codec actually is even cheaper than the physical codec. But beyond that is that you can install it on, they call it COTS, or commercial off-the-shelf servers. So you can go out and buy your own server or have a server in the cloud that you're using, and you can deploy our codecs, to it. As long as it's Linux, ours installs on Ubuntu. So the box itself, you're going to be able to save money. Now, I would say that really the benefits of the virtual codecs really comes into play for some of our larger customers that are going to have many of these codecs. Okay. If you're only talking about one or two codecs, okay, you're going to save, a little bit. But when you start talking 10 codecs, 20 codecs, 30, or even more, up to even into hundreds of codecs, the way that we do the virtualized version of this is that we're using container technology, which I maybe make some assumptions here that you guys know what containers are, what pods are when I talk about virtualized environments. If not, I'm happy to talk about that as another topic. Is that you can deploy these things in an automated way. Okay, you can spin up a whole new codec with a few keyboard strokes, as opposed to we need 10 more physical codecs for this project, actually unboxing them, putting them in racks, getting power, all this kind of stuff, might is down to typing out deploy 10 codecs within my Kubernetes farm. So when you start talking larger projects, larger installations, the virtualized route is almost a necessity to be able to have the maximum flexibility while trying to reduce your expenses. Okay. This graphic here showing a virtualized DAB network. No, keep in mind, much of my material is coming from Europe, guys, so you're going to see a lot of DAB stuff. But it's the concepts are the same. Here's an environment where I'm showing, hardware codecs maybe at the studio being in a mix with our virtual APT codecs. And what you'll see here, this code you'll see in the middle under where it says network head end, where I'm going from the studio to the head end. And I've got codec 1, codec 2, codec N. Just, representing here, you can almost on the fly scale these things as needed. So we have a pop-up studio. We've got contribution coming from the field, from people's homes even, or from vans, or from stadiums, etc. Adjusting the head end or wherever my receiving is now down to can be a matter of minutes as opposed to days or weeks of planning. In this example here, I've got a head end doing some DAB encoding, and then going out to over a distribution network, eventually to my transmitter sites. The way we've done virtualized too is, and this is as a benefit to our customers and also to our kind of ecosystem of products, is that they're our virtual or software codecs are fully compatible with our hardware codecs. Okay, because it's not, typically we're not doing projects anymore, or well, I shouldn't say anymore, but we don't do typically projects are going to involve some sort of in between stage where we're mixing the old with the new, and that's what we wanted to be able to do. And so we can come in, replace hardware codecs with software codecs in the middle as needed. We also, too, as you get to, the transmitter site, and again, this is, our world here, WorldCast is typically for these codecs are many times like a studio to transmitter site. It's going to be, I would say, a very typical environment. We do have some other use cases, big ones, especially around stadiums and things I'll talk about later. But what you're looking at, this graphic here is pretty typical for us. We're at that transmitter site. I am going to have either a physical codec, or now because we've now taken the time to containerize our codecs, we are able to now, and for a few years now, we've embedded that same codec into our transmitters. Okay, so I can have that virtualized or software codec now, not just running on a server like in the head end like we see here, but I can have it running on another one of our boxes, our transmitters. So I've got physical codecs, we've got virtualized codecs running inside servers, and containerized codecs running inside our own transmitters, as well as other types in the industry. We're working with some other partners that we might have even more options out there in the future, but I'll leave that as it is. The way we do it is, and maybe you've probably seen this with other products, is that it's not just, although the codec itself, you can think of it as this standalone thing, right? It's embedded right in the whole picture as part of an ecosystem. And what this slide here is just mentioning is, I will say this about Kibio. So Kibio is for WorldCast. It's our network management software. And as you have a scaled system of codecs, it is almost a requirement to have some kind of management. When we do projects, obviously we like it when the customer wants to use our network management platform, because we natively tie it into, the virtual codecs to everything else that we do. But if you want to use another one, that's totally fine. Our virtual codecs have remote, interfaces just like the hardware ones do. So whether it's SNMP or API or a web GUI, you can still do that. But you have to remember that once you've got, 10, 20, 30, 40, 50, 100 of these virtual codecs in a network, you can't effectively just have 100 Chrome tabs open to do your management of this thing, right? So having a single pane of glass way to visualize the health, the operational status, the health of the underlying computer, or like server side of this, the Kubernetes side of it, the container side of this, having some visibility into that in a single page becomes really important, right? Otherwise it's extremely hard to track this stuff down. And I will say, from because as you compare the management and troubleshooting of virtualized stuff versus hardware stuff, there's something to be said for how easy it is to track down where the problem is in our hardware chain, right? I know I might have a box that's literally got red lights on it, let me know like something is not right. I can go through each point and test to see if I hear my program at different points in the chain. But as I move to virtualized stuff, that the ability to do that gets a bit more complex, and it's a bit more difficult to understand exactly where my audio is. So, and who is actually working on it. When I say who, like which server, which process, which container is doing this kind of thing. So having some way to try to like help understand that is a benefit. SureStream, you're going to see in a lot of my slides what SureStream is. This is a WorldCast thing. For us, we use SureStream is our technology, and what it is, it's ultimately it's packet duplication. But we can take an audio stream, and we can send it out. Let's say, typically we're going to send let's say an audio stream from one codec to another codec. We can send it out over two different networks. So let's say our codecs typically have two network interfaces on it, and I'm going to send one stream out one interface, and second stream out the other interface. But the packets are actually exactly the same. And so what's happening, they're just having different addressing, like, IP addresses or destinations to them. So they're both going, this can either happen on the same network link or it can happen on separate network links. And then the other side, as it receives it, it's just going to be who wins the race. So I receive the stream, and whichever one gets there first, that's going to get assembled into the stream. And so this is not new. Like we've had this for quite a while, and we've run tests where like we are running audio streams, across the Atlantic for like almost years at a time without dropping anything. So it's makes it very stable, and also has a lot of flexibility in how you set it up. So you'll see some SureStream stuff in there too. APT-MPX, I mentioned compressed MPX signal, low bit rate, low delay. This is another key thing for us. Then Virtual Script Easy is our automation engine here. So we, for a long time, have had in our Automat brands, Automat control boxes. These are your remote control studio boxes, GPIOs, serial control, also SNMP, kind of on-site monitoring and control. And so we have a virtualized version of that now too. So, not just our codecs, but across all our brands, we're more and more virtualizing these things so that they can run inside containers. And down below here, I've mentioned both Docker and Kubernetes because we do either. So if it's a smaller installation where we are going to run only, let's say, one or two codecs, we can easily set that up using Docker on a server. And if it's going to be a high availability situation where we are going to we want to run across multiple servers, many codecs, and we're going to use Kubernetes for that management. Now, if you're not familiar with those terms, Docker, Kubernetes, these are both, by the way, kind of open source products, and they're just really about management of virtualized containers. Okay, so don't get too caught up in that and how they work. Think of it like this: Docker's for a smaller kind of management, like only a few containers, and Kubernetes is scalable to hundreds and even thousands of these things. Okay. All right. Now, let me get out of this guy here. Because what I've given you is really a very, generalized overview here of what we're doing. Now, this next one I'm going to talk about gets more into some of the more technical details of what we're doing with these things. So one of my colleagues based in Germany here has put this presentation here together for me. And it's mentioning, this is going to be mentioning some of the same things here that I've been saying, how with the ability of having these things virtualized here, I've got more scalability, I've got more backup strategies. One thing I will mention, because it kind of, yeah, well, it's kind of obvious when you think about it, is the question is, well, how do I get audio into my virtualized codec that's sitting in some container on a server and I'm not even sure where it is? We do have ways that you can get the codec to talk to, like, say, a physical sound card, but out of the box, our virtual codecs are receiving already an AES IP stream. So what the environment you might see our codecs being used in is where there's something beforehand that's already giving me an IP stream. Okay. So there's a use case, which I'll talk about last, that I mentioned to Barry before, of a larger customer in Europe, where they're using in the studio, coming from the studio into an Omnia sound processor that is spitting out AES 67, and then those going into our virtualized codecs, which go through their network and end up at another codec on the other end by the transmitter sites. So AES 67 to get in. And then we got SureStream here I mentioned for packet loss, and then Akibio being the front end to monitor and manage this stuff, and then the individual codec. Each codec you can still go to each codec's IP address and get into the web GUI on these things. So it mentions here software architecture for high availability. Okay, yeah, hardware agnostic. We don't care what you run it on. We don't care about the server. The container format here being Docker with orchestration by Kubernetes. High availability, or HA, you may have heard of. It's actually a thing. Like, that term, high availability, is meaningful in that this is something where you can set it up in your Kubernetes management. And by the way, Kubernetes also, it's another open source management tool for containers. You can set it up so that I can make sure that I always have so many copies of my codecs running. And you can set it up so that I can say, okay, I have got 3 servers, and I always at any one time need to have, let's say, 10 codecs running. And it will, on its own, make sure that I always have 10 running. So let's say I've got 5 running on server A, 5 running on server B, and I go and I lose server B. Well, it's going to automatically know that and spin up those 5 that disappeared on me, it'll spin those up on server C, as an example, right? So that's my high availability. So I can take a big hit, I can lose a server, and no one has to do anything. And I may not even notice much of a blip. Like we're talking a few seconds maybe before that codec, an exact copy of that codec, the same configuration, the same settings, the same IP address, all that stuff is already up and available, right? So that's what we mean by high availability. And yeah, so yeah, it does say here you can also run them in a dedicated server. And there's some kind of algorithm here. Yeah, this majority voting algorithm as to how that all gets handled. I don't get into that world. We just, I get more into like let's get it configured and set up and then let it do its magic. So the terminology for these things, it's like if you don't have a lot of experience with virtualized stuff or containers or it can feel like a lot, although these things tend to repeat. So if you have worked with a lot of virtualized stuff with other vendors, this stuff is going to be probably familiar to you. The differences between what a virtual machine is and a container. Pods being a group of containers, a node being the physical computer, cluster being groups of nodes, the orchestration being like who's going to control where these things are running, where these pods and containers are running. Pod affinity, this is more of like a Kubernetes kind of thing where it's like determining who's allowed to do what. And then there's like this voting, thing for deciding who's going to do what. But here's a picture of the high availability cluster here on the physical machines. Now, I know it may at first look a bit complex here, but it doesn't have to be. What you have to just envision here is I've got the 3 physical servers I mentioned. I have got in this picture here, they're showing 24 up to 24 codecs or pods running in each one of these things, being distributed through a control plane. Okay. And I won't get into like exactly how it works, but essentially, like I said before, you can take down one of these, you can lose a server, and the pods that were running on it will very quickly, like microseconds really, or milliseconds, start to spin up in another server. Okay. Okay, yeah, you can also do this stuff in single node. You don't have to do the high availability. Says on request, we also offer already installed systems on hardware. Yeah, so this is mentioning, yeah, you can mix and match these things. We'll just say that. Having a management layer to help with the dashboards, I mentioned before how important that is. We also are getting into, managing the licensing with these things in an automated way. So I don't have to, spin these up and then go get licenses. Like all that can be automated and tied in. Now, okay, this is a complex looking picture, but it doesn't necessarily have to be. The idea here of what we're showing, and this is modeled after some of our customers that do this, where I've got, studios. Each studio has access to 2 redundant networks. I got a blue network and a red network here, everything going through a head end. So if I am sending content from one region to another, this is a classic example for us of having of moving my headquarters codec farm into a virtualized appliance. So, and this is a real example here. So we have a large deployment. I was helping out with this recently, where we have a large deployment in Japan, actually, where this particular customer is running hardware codecs at various venues and stadiums around the country, with a head end with a giant farm of these codecs, and in the process of basically, taking those I don't forget how many racks it is, like 10 racks of these things, and down to one rack of servers, right? So that's, that's not unusual though. That happens a lot in this business. You hear about stories like this, and that's exactly what this is about, is getting rid of that physical plane into a virtual plane here. This is another example here of an end-to-end content contribution. Again, I've just got two redundant networks. In this case, everything does not have to go through, a central location. I can go directly from point to point here. Again, typical environments where we are seeing virtual codecs being part of the conversation for these kinds of networks. Okay. Here's one showing how I've got my WAN here, and then a LAN on the back end. Local, content providers here. Here's an example here of my 18 programs with studio transmission links. So, from here, this is where I might even switch over to the use case that we had. And I will. There we go. So in this user story here that I wanted to mention is that the environment is like this. I've got multiple. This is a organization called 100% Radio here in France, and these guys have something like here it is, 16 program feeds across 50 FM frequencies. So maybe you guys know, they do radio in Europe and in France, and particularly a little bit different than they do here. In Europe, you're going to listen to a program, you're going to know a program, you're going to have your favorite program that you listen to. And as you drive around from city to city, your radio it automatically tunes to a different frequency, right? So you stay on that program. Here it's in the US, we listen to a frequency. We know that frequency. We know that that's our channel. That's our station, and it has its program. So it's a little bit different in how it works. And and by the way, as a side note, in case you didn't know, maybe many of you do already know this, that in Europe, that change of your program from one frequency to the next, as you move from town to town or city to city, it's coming out over RDS. So like, the radios will receive, oh, if you want to stay on hits radio, you've got to retune to this frequency. Anyway, so that's why you have a situation like this where I can have 16 programs and being sent out over 50 different frequencies. That's how that works. So that's a situation. Let me go down here. My 16 programs coming out of studios, going into Omnia, coming out of Omnia into our virtual codecs, going into their network. And then you have to imagine now I've got 50 transmitters, some of which are our own Acriso FM transmitters that have a built-in virtual codec, like I've been talking about. And some of them don't. They're older here in the graphic. It says older generation FM transmitters where we're putting in a physical codec here to receive that. So benefits, same thing that I've mentioned before. Lower operating costs, because you have less hardware, using less energy, less maintenance, right? Low bandwidth usage, reliable transport across the network, consistent sound quality, full control with real-time supervision over the KBO monitoring, and scalability as they add new programs. It's much easier now to add the codec, add to a codec farm or a Kubernetes deployment than it is to to rack new equipment. So it was a nice use case for us. Now, Barry had asked me, do I have any good US references? And I can tell you right now, well, I do. And I will have ones that I can name probably next NAB. But I'll say we're working on one that's a national radio organization that has used our audio hardware codecs for many years. Um, and they are very interested in replacing those with our virtual codecs. Now, we're still in a proof of concept phase on that project because they had a few requirements for those virtual codecs. We're working on adding some features to that. But that's one. And then we have another one where for a long time, we have our physical codecs have been used by a professional sports league for a long time, where they have the codecs at every stadium and taking that audio and sending it back to a head end location. And so there's a new project we're working on with that that is also in a proof of concept phase. So I don't want to mention it until it's a real project. But it's a very similar thing where they want to they want to get rid of these, in this case, like hundreds of these physical boxes, and they want to replace them with virtualized codecs. So it's this is like a real growth area for us as a company, but it's not so much um, about that as it is like this is the way that many of these boxes are going, that the boxes are being replaced by virtualized appliances, you know, and from what I've seen, there's like this almost kind of like this promised land that we're looking at where instead of a rack of equipment, there's just a single, computer in there or a single server. And while you might have had a group of different vendors, you still might have a group of different vendors, doing different functions, but they're all virtualized containers now running in this, commercial off-the-shelf stuff. So, that for our piece, that's what we are working on to remain, to make sure that we still have stuff that our customers want, which is they want more and more virtualized stuff and less hardware stuff, to save money, to make it scalable, to have more flexibility, to have more, um, I would say, reliability in the like the configuration of these things and the quality, because I think that's another thing is that when you are working with virtualized stuff, this gets more into how containers are I'll say spun up, but it's not maybe not the great word because I still think sometimes in terms of like hard disks and things. But the way these containers get spun up is you essentially have a file that has all the configuration that you want to feed into this thing as it starts up. And so you can have that configuration. It works almost you can almost think of it like a preset. So when I spin up a new container, it's like opening a hardware box and having the exact specifications for my need already kind of pre-programmed in, right? So I know for sure, for 100% certainty, that I can cookie cutter these codecs as needed, and they're going to be set up exactly the way I need them to for my network. Okay. So there is some complexity in that, some added complexity in that, where people like myself get involved with the customer to help them, get these things set up, to help them understand how, the Kubernetes world is working, because not every organization is going to have maybe that skill set already in-house, so we do get part of my job and part of, I think working with these tools is a lot about, frankly, about training, about learning how these things work. How do you work with them? How do you set them up and get them, working the way you need. So that's another part of it.
Okay, Cyrus, let's maybe hear a ground level thing.
Sure.
Talk about the difference between your hardware codec and the virtual codec.
No.
As far as the listener is concerned, will there be any difference?
To the listener, no.
You're going to tell me that if we're running, let's say, AAC plus on either one of them, it's just going to pass on from one to the other.
Yes, yes. So to the listener, no, Barry. There is some significant stuff though in terms of differences between the physical and the virtual. In the virtual world, when you start talking about AES 67 and in the IP world, we have things like PTP, which must be considered. Okay. And so getting the PTP right in this network and making sure that we are handling PTP right inside these virtual codecs, that was a challenge for us, getting these kinds of things working right correctly. So, there are some considerations like that. And in addition to, because we do have sometimes we get questions about, well, like I want to what if I want to install, this sound card into the server and I want to pick that up on your virtual codec, and that's not what we do yet, right? So we're only going to be already accepting that IP AES 67 in. So, there are some, yeah,
Well, you're virtual.
yeah,
Uh,
yeah,
Tyline and you guys really have pioneered this business of SureStream. Tyline has its own
yeah.
version. Um, One of the questions that came up here in the chat box from Ray Lewis: do you have some form of adaptive error correction similar to the Comrex crosslock, which continually adapts compression settings and FEA dynamically during changes in internet conditions?
The I don't think we have anything that we do like in some proprietary way to handle those kinds of conditions but we're more relying on the higher level protocols to handle these kinds of things. But for if it came down to like a specific, I would say a specific type or a specific kind of interruption that he's interested in, it'd be best to just drop us a note and I can get it in front of the R&D guys.
So if somebody was planning a system like this, let's say,
Yeah, yeah.
what would be the normal minimum delay that you would recommend so that there would be enough uh, pickup to take care of these between the two? Would you say 500 milliseconds, 2 seconds? What would be your recommendation if you're going to go with a dual feed?
It's pretty quick. It's pretty quick, Barry. It's less than a second.
All right.
Yeah. I mean, that's what I'd say now. It might even be, it's probably less than 500 milliseconds as well. I just don't want to put words in the engineer's mouths.
Well, basically, if you're going
Yeah.
to do a SureStream, and you're assuming that at some point one or the other are going to have this latency issue, maybe a dropout, maybe just a delay, and so you want to be able to have a buffer that no matter what happens, that even if both of them glitched for a second, you would not lose programming.
There is a small buffer. I just don't know exactly what it is. But it's on the order of less than a second.
Okay. Harold, you had a question here in the chat. You want to bring it up? Reach for your unmute. Here, let me do it for you. You're open.
Okay, I was trying the space bar. It did not work. Anyway, the SureStream is interesting, and the high availability is also interesting. I'm wondering about running the same audio through codecs in two servers, having them both stream out to the same destination, and then whoever arrives first, that packet gets aired. So it's sort of moving the SureStream thing back to the server and getting further redundancy there. So you have no loss at all when you lose a server.
That's a good idea, Harold. I don't know how, I don't know if I think that is definitely possible to do. I just typically, you know, in that kind of situation, I might be doing, let's say both ends of this, I've got virtualized appliances, right? Yes, I could have two, two going to one. I know it's possible. I just don't remember the configuration of how that gets set up, but I do know that we have people doing that. That's different. It's different than SureStream, but it's a similar thing. Now, if you add a SureStream on top of it, yeah, now you've got four streams essentially going to that target.
Yeah, I was still just looking for each of your transmit codecs, and on the receive end, it's receiving the two, and figuring out, I'll pull a packet from here, I'll pull a packet from there, whatever it takes to
Yeah.
get a steady stream going out.
Yeah, yeah.
I had another question, trying not to take over. I'm familiar with data compression for audio, where we're largely taking advantage of masking effects of audio and how our hearing works.
Mhm.
How do you compress a multiplex signal?
That's a good question, Harold. I'm not the compression guy, for this. So I don't really know offhand how that happens for the multiplex part of it. So I don't know. I have to get back to you on that one. I don't know.
Okay,
No.
that's fine. It was just, I was
Yeah.
curious as to how that could be done. Thank you.
Mhm.
Isn't it true that for the most part with a codec, you're not dealing with compression. You're trying to send a wideband clear signal, and the compressor would be an add-on before or after the codec. Yeah.
Yeah. Yes.
Okay. Roland has a question here for you about virtual codecs. Sounds great, but do you also have them for IPTV, like streaming SRT? And he'd like you to leave your email, and would it be possible to get a PDF copy of the presentation?
Yeah, absolutely. And in fact, let me
Got a screen for us.
yeah, listen, let me drop in the chat my email here. It's my name, so you guys have it, and then see that. Here you go, guys. So in the chat's my name and my email. So
Got it?
feel free to ping me about anything here. Now, okay. So what was the other question here, Barry?
Got a PDF of your presentation.
Yes.
If he sends you
Yes.
an email, you'll send it back.
Yes. Send me an email. I'll send you what I got.
Okay. Anyone else have a question for Cyrus here?
Barry?
Yep.
If I can. So, in sort of a broader question, in an era where some of the industry is trying to move to, simply 2110 or Dante, et cetera, where does the codec fit in if you have program origination and destination equipment that is 2110 capable? What is the role of the codec in the installation here? Why can't I just connect to 2110 devices, and where does the codec fit in?
Well, because already just data. Well, yes. The answer to I'm just now seeing the chat here, guys. I apologize. I didn't realize all these things were coming in. So to that question, though, with the SD2110, the it's a piece of it, right? So SD2110, especially in an IPTV, world, defining video feed, multiple audio feeds, elementary feeds, these things. We are uh, working in projects that are all SD2110, in-house. And so, we are essentially just a piece of that. We're a piece with fitting within, trying to fit within that framework. You said without the video. So, it's the multicasting piece of this is kind of, to be frankly, is a little bit new, I wouldn't say new, but it's like it's not necessarily like um the typical situation for us, where we're more like, site to site is usually, in an environment where we are, except for when we have, let's say, the larger content networks like with stadiums and things like that, where there is an SD2110. So, the way I'm understanding this, of how we do this, is that we are compliant for SD2110, but we're just the audio piece of that. Does that make sense? I don't know
I'm
if I'm,
trying to formulate a yes or no, and I'm sort of
yeah,
standing on both of them here. See, I understand that with 2110, of course, you're sending out uh, uh, it's they're not uh, there's no return path in it, so error correction becomes a bit of a, I don't want to say a black art. There are several well-known solutions to this now, but the other
so
option is, if you go codec to codec, the codec, of course, has within it, as you showed with SureStream and whatnot, it has mechanisms to assure 100% error-free delivery if you don't use a codec. Uh, if you're trying to remove that piece, you have to come up with some solution for error correction that probably requires something else from what I've seen so far.
yeah. So let's see. Uh, the I guess the other way to answer the question is, AES 67 is just like SD2110 builds on AES 67, right? Adds other things, PTP and other, things to it. So as we are getting into projects, this product is very much dynamic, in that the next big project that we look at, it seems like this happens every big project. It's like, next big project we looked at, it's like, oh, we are SD2110, and these are the pieces that we do, and we need your codec to do these pieces. And so we say, okay, well, we already do that one, that one, that one. Oh, we don't have SRT yet, so let's get that added. And the project before that, it was like, okay, we're doing PTP in this way, and he has to make sure that this works in the codec. So as a project person, the reality that I see, Ed, is that, the customer is telling us, okay, we are fully SD2110. It's like, okay, great. We think we are mostly there. Like, what else do you need? And so they say, okay, well, this piece is missing, and this piece is missing from what we see. So they say, okay, great, we'll get that added. So, in the reality, that's kind of how it's working. It seems to be working for us.
Yeah, like I said, and I don't want to monopolize too much here, Barry, but if we go back, a generation earlier, and I was doing a college sports event from a venue, I would be traveling with one of your codecs, and there would be uh, a network connection there to get it to an ISDN circuit. So if I move ahead a generation, I get to a booth, and maybe there's a network connection there, or a connection to the school's WAN or something. And now I'm trying to connect to a form of codecs that are out there in the cloud. It's the same thing I used to travel with, but now I don't have to travel with it anymore. I just have to connect to it over over a network, which is, an obvious way I see where the codec is still in play, but we are now, a generation further ahead.
Okay.
Thanks.
I saw
Thanks,
your
Barry.
hand. Thank you.
Mm-hmm.
Jeff, I saw your hand up. Yeah.
Yeah, I was just wondering if the Sure Stream is that a type of stream splicing that to utilize a phrase from Gates Air, and are they compatible on one way or the other?
Jeff, I'm sorry. What was that? One more time. I'm sorry.
The Sure Stream seems like
Yeah, yeah.
a type of stream of the stream splicing of that Gates Air uses. You said earlier that it was your term for this. Would they be compatible in any way, shape, or form on one way or the other?
Hmm. I
And
don't.
and
Yeah.
actually, there's the second part of that question actually goes to Ed. Whereas if that is the case, would you be able to use that in the terms of the virtualness of of the cloud, the way Ed goes forward that generation?
Well, I can quickly answer that for the interoperability with the Gates Air stuff. We're compatible. The SureStream stuff is, I'm almost certain, is not compatible with things that aren't labeled SureStream, and so I don't know exactly what they're doing with their side of it. It might be similar, and like how it works underneath, it might be very similar. But I'm not aware of, at least on the technical side, of us doing installations with that. Now, having said that, though, Jeff, that's just the SureStream part of it. It's a virtualized codec. We're sending out, we can send out standard stuff. So, there's no reason why, if something can receive an AES67 or whatever, or an APT MPX, whatever, it's fine. We can send to other equipment. So in that way, the SureStream part itself, I think, only talks to other SureStream stuff of ours. Yeah. I see in the chat here, my old colleague here, Andy Butler, and see, he says, on a practical note, where's customer support for us? So for us, support based in France, and also for the Americas here in Miami, Florida. I'm obviously in Miami. I'm not in France.
Have we any other questions from the floor for Cyrus? I think you've pretty much given us the full picture, and certainly the breakpoint where numerically it makes more sense to go virtual. And for those that like the older system, the APT MPX that runs complete stereo, RDS, everything all at once, correct?
Yes. Yep.
All right.
No, this was great, Barry. I appreciate it, having us come on here, and I don't want to, I sometimes talking about the software codecs, you do a lot of comparison with the hardware side, and I will also to be transparent, is that we still have a lot of demand for the hardware, in fact, some of our customers in our projects, they're looking at adding virtualized as a parallel workflow to the hardware.
Sure.
So you kind of think of it like that way too.
It makes a lot of sense because depending on your scale, there are things you want to be able to see. You want to be able to follow your chain. Harold?
Yeah, I think the virtualization is interesting, and that it seems as though you could just take the same software that's currently running in the hardware boxes and stick them each in a container and there you are. It's that the power of computers now has so vastly exceeded what's needed for an individual box that we can just run them, a whole bunch of them on one box. My very limited experience with virtualization is renting a virtual private server. And to me, I have root access to a server. Who knows what else is running on there? But I've got Alma Linux and root access, and I assume that everyone else is on that same piece of hardware, is running their own operating system, and it all works. Pretty amazing stuff.
Well,
Yeah,
again, Cyrus, yep.
I was just going to say that's a nice, comment there that it's true. The power in the boxes now is so cheap. Or I mean, like the processing is pretty cheap, for the stuff that we all do, So you can start comparing it to, asking ChatGPT, what, you should get for someone's birthday. Probably uses a lot more processing than we do to send audio across the world.
Okay. Well, again, thank you so much for being with us today, Cyrus, and
Mhm.
certainly want to invite you back another time and discuss these different products in a greater way where SureStream can be utilized for folks that are having, well, we're moving from STLs to internet so many places.
Yep. That's true. That's true. Well, no problem, Barry. It was great to be here, and thanks for having me, really. And happy to come back if given the opportunity.
Okay.